been asked to answer question number 12 from the P1 textbook, chapter 7 review exercise, a question about radian measure. Tells us about this glass prism A, B, C, D. Okay, and this is a cross section of the glass prism. We're told that the length from AD and BC are both the same, 4 centimeters, and that this is a right angle between AD and BC. We have right angles. Okay, that's the information that we're told. So here we have a right angle, and here we have a right angle, 90 degrees. Okay, AB is the arc of the circle. So AB is the arc of the circle with center O, radius 6 centimeters, and the angle AOB is 2 pi radians. And the perimeter of the cross section, is 2 times 7 plus pi centimeters. That's the perimeter of this whole cross section. So part A, it says show that 2 theta plus 2 sine theta minus 1 equals pi over 3. Alright, so obviously they've told us about the perimeter of the shape, so we've got to deal with the perimeter. So let's try to find an expression for the perimeter in terms of, what we can find it in terms of, like probably in terms of theta, and then equate that to the exact value that they gave us of the perimeter, and then see what happens from there. Okay, so let's first of all think about the perimeter of the shape. Now, if we think about the perimeter of the shape, you have AD and you have BC, these two lines. You also have another straight line which is CD, and then you have the arc AB. I'll just show that like simple, the arc AB, the arc from A to B. Right, so those are all the lines that make up the perimeter of the shape. Remember, the perimeter of the shape is the length of the outline that encloses the whole shape. Okay, so AD and BC we both know are 4. So we got the perimeter equals 4 plus 4 plus. Now CD, okay, is the length of this line from here to here, which we don't actually know directly. However, if you think about it, they told us that this is perpendicular to this. AD is perpendicular to DC, and so is BC. So A and D, the length from D to C is the same length as from A to B. It must be the same length. Okay? And the length from A to B is a special part of this sector of the circle. It's called the chord. It's like if you complete the circle, this would be the chord of the circle. This would be a chord. Okay, and we can work out the length of the chord from this triangle. Okay, if we can work out the length of AB, that will be the same as the length of CD. And we have a few options. We can use the cosine rule. We could use the fact that this is a triangle, okay, which is if it's an isosceles triangle. So if I drop a perpendicular from O to AB, then it will make 2 right angle triangles. So I can use SOHCAHTOA. I'm going to use the second method I mentioned, although the first method would also be perfectly fine. And the main reason I'm going to use it is because I can see I need to have a sine. The cosine rule will end up with a cosine, which is still not a big deal. We'll still be able to change it from cosine to sine quite easily. However, I think this will be less work. So let me just drop a perpendicular from O to AB. Okay, in which case this angle now is not 2 theta, it's 1 theta. Okay, and this length, let me call this point P. This length is x, AP is x, and we need to find AB, which is twice of x. Okay, so if I look at that triangle OAP, so I have a triangle OAP, just redraw it here. That's x, that's O, that's A, and that's P. Okay, that's theta, and that's 6 centimeters. So we can say that the sine of theta is equal to x divided by 6. So x is equal to 6 times the sine of theta. Alright, therefore our length AB is equal to 12 times sine of theta. Therefore CD is equal to 12 sine of theta as well, because AB and CD are the same. I'm not talking about the arc AB, I'm talking about the line between A and B, okay, not the arc. Okay, so that means CD is 12 sine theta. That's 12 sine theta. And plus AB now, the arc AB. Okay, so let me just be very clear about this. The arc AB is subtended by this whole angle. This angle number is 2 theta, the whole angle. And the length of an arc is given by r times the angle in radians, which is subtended by. Now, be very careful here, because this theta is a symbol representing whatever angle this is, and the angle in this particular case is 2 theta. So the theta must be replaced by 2 theta in this formula. So you're going to have r, okay, r is 6, so 6 times, and angle is 2 theta. Okay, so that gives you 12 theta. So if we just simplify this, you get 8 plus 12 times sine theta plus 12 times theta is the perimeter. Theta is the perimeter. And we also know from here that the perimeter is 2 times 7 plus pi. So we also know that the perimeter its actual value is 2 times 7 plus pi. So we know that these two expressions must be equal to each other. This must be equal to that value. So we can say that 8 plus 12 times sine theta plus 12 times theta is equal to 2 times 7 plus pi. Now if I divide everything here by 2, if I divide both sides by 2, okay, just to get rid of this 2 here, instead of expanding, I can just divide by 2, because the 2 will go. This will give me 4 plus 6 times sine theta plus 6 theta equals 7 plus pi. Now if you look at to see what we have to prove, okay, we have to have everything on one side except for the pi term. So let me subtract the 7 from both sides, in which case, and let me write it in the same format, to the pi, the theta first, and then the sine theta, and then the number. So I'm going to write 6 theta plus 6 sine theta, and you have 4 minus 7, which is negative 3 minus 3 is equal to pi. And final step, we have to write it as pi over 3. So that means both sides of the equation, if I divide both sides of the equation by 3, if I divide by 3 both sides of the equation, I'll end up with the pi over 3 that I need on this side. And each of these has to be divided by 3. So 6 theta divided by 3 is 2 theta. So I have 2 theta, and 6 sine theta is going to be 2 sine theta. And minus 3 divided by 3 is minus 1. And this is what we had to show. And this is what we found. And we worked out an expression for the perimeter. So that's part A complete. Okay. Then it says verify that theta equals pi over 6. So part B says verify, okay, that theta equals pi over 6. Now if theta equals pi over 6, then when I substitute theta into this expression, pi over 3 should come out, okay, because it should satisfy this equation. So let's substitute theta as pi over 6 into here. So you have 2 times pi over 6 plus 2 times the sine of pi over 6 minus 1. Now what does that give you? That gives you pi over 3 plus 2 times, now the sine of pi over 6 is a sine of 30, which is a half. So 2 times a half, okay, and you're going to have minus 1. So that gives you pi over 3 plus 1 minus 1, which is pi over 3. So we can say therefore theta is equal to pi over 6. Okay? Because it satisfies that equation. Alright, then it says find the area of the cross section. So we now know that theta is pi over 6. We also know that the length CD was 12 sine theta. Okay, let me just confirm that. Yep, 12 sine theta. Okay, so that means CD is going to be 12 times the sine of pi over 6. Now pi over 6 is 30 degrees. The sine of 30 degrees is a half. That means CD must be equal to 6 centimeters. So I know that this is 6 centimeters. You just write 6 centimeters there now. So I know that this is 6 centimeters here. Okay, so the area of this cross section, okay, if you think about this chord AB, alright, this is a rectangle, 90 degrees, 90 degrees, this of course must be 90 degrees as well, these two. So if I find the area of the whole rectangle ABCD, and I subtract from it the area of this segment of the sector from AOB, then I'll be left with the area that I need. Okay, so let's go ahead and try and do that. Okay, so we know that the area of the rectangle, okay, the area of the rectangle minus the area of the sector is the area of what we need. Okay, try to draw it best I could. Alright, so now the area of the rectangle, okay, is 6 times 4. So this is going to be 6 times 4 minus the area of the sector. Now the area of the sector is given by a half times r squared times theta, which is the area of the whole sector. Okay, and we're finding the area of the segment, this segment of it. So it's a half times r squared times theta, which is whatever angle's over here. Alright, that's the area of this whole sector, like this pizza slice shape. If I take away from it the area of this triangle OAB, I'm left with the area of the sector. So I'm going to take away from it the area of this triangle. So this formula here is actually exactly that. A half r squared theta is the area of the whole sector, minus a half r squared sine theta. Remember, we have two sides, so that's why the r squared, times sine of the angle between those two sides gives you the area of the triangle. So a half r squared theta minus a half r squared sine theta will give you the area of the sector. Now, be very careful here. In this case, our theta is the angle from there to there, which is 2 times pi. Well, sorry, 2 times pi over 6. So this angle is pi over 3. Okay, 2 times, okay, because we know that theta is pi over 6. So this is 2 times theta, so it's 2 times pi over 6, which is pi over 3. So the angle from here to here is pi over 3. Okay, so now you're going to have a half times r squared, so it's a half times 6 squared, times, and you're going to have theta, which is pi over 3, minus the sine of pi over 3. The sine of pi over 3. Okay, so this is going to be 6 times 4, which is 24, minus a half times 36, which is 18, times pi over 3, minus, now the sine of 60 degrees is root 3 over 2. Okay, so that gives us 24 minus 18 times pi over 3 is 6 pi. Minus times minus is plus, and we have 18 times root 3 over 2. The 2 and the 18 cancel, leaving us with 9 times root 3. Okay, so the answer, this is the exact form, but we'll give the rounded form. Now the rounded form of this answer is going to be 24 minus 6 pi plus 9 times the square root of 3, okay, which gives you 20.7389, 20.7389, which you should round to 3SF if nothing is mentioned. So it's 20.7 centimeters squared. And there we have the answer to this question.